Okay, so section 14.3 is about decibels on log plots. And my whole career, I never really had a good class about it. I think there's not that much to do, to talk about in decibels. But a lot of my job applications, or people who tell me they applied for jobs, had questions on dBs. So I think it's important to talk a little bit about it. The reason is that when we talk about Bode plots, the magnitude graph will be given in a semi-log scale, where the y will be a log and the x is just frequency. Oh man. So from 0 to almost infinity, it's really 2 pi f. In here, the amplitude of the transfer function will come by decades. So it's whatever, 1, then 10, then 100, then 1,000. It's much easier to plot this way. It becomes linear. A lot of the circuit responses will be super simple this way. And a lot of times we're not even maybe going to use the dB scale, but it comes from logs. So the gain in power, mainly if you're buying an amplifier, so most amplifiers, for example, car amplifiers, or if you do work with sound systems, or if you work with radio frequencies, so RF amplifiers. If we were in class right now, maybe I'll take most people to my lab and show you an RF amplifier that has 50 dB in gain. It's super heavy, so it's not that easy for me to bring it over, and it would also possibly explode the dock cam again. So let's go back to this. The gain in power is measured usually in decibels, but the original definition of gain was in bels, and it was log 10 of the power out, usually the output power over the input power. But really you can be comparing two powers, P2 over P1. Then you take the log base 10 of that, and you get the gain in bels. Much, much more common is the decibel. So I think this is a typo in the book, actually. So this is you can remember the word 10. I think you can remember the word 10. So this is the word more or less in Portuguese for 10. So you multiply it, the log 10 by 10, and you're done. And then we call this the dimension is in dB. So I'm going to also tell you that the confusion is that there is also the gain in voltage that's given in dB. But then, instead of multiplying by 10, what happens is that power is really voltage square divided by resistance. But so assuming the resistance is the same for both the input and the output, instead a reasonable assumption for power is also the voltage squared. So the gain in dB for voltage is 20 log 10 of V2 over V1. There's a chance you end up getting the same number, because obviously this 2 comes from the square of V2 and V1. But this is very confusing. Which of these two expressions to use? So I'm going to suggest for job applications, if somebody asks you a question about decibels, that you say it's 10 log 10 of P2 over P1. And here's a question. So an amplifier system that you buy commercially, specifies a 30 dB gain. If your power supply hopefully is compatible with the voltage of your amp, can supply up to 0.3 watts, so 300 milliwatts. What is the power you will get from the amplifier. I'm assuming you guys can do this very easily. This will be the please post on Blackboard. The answer until the Monday class, before Monday class.